Okay, good morning everyone. So today the things we're going to do is about using the sound capture to create a spectrum, and we can do some custom modification for the spectrum using different type of geometry, color to represent the spectrum. So let's start and take a look of that about the result. So when I speak, as far as you can see, the color dots will move based on my tones and frequency and create this kind of music visualization. And for sure, you can create more curve right here. But if you create a more curve, it will uh, create more loading for your computer because we need to do more computer to generate the result. But anyway, that's the things we are going to do for today. I will start to record. So first things, let's take a look of about the script we're going to do for today. First things, the key is still like this. As far as I can see, it's about to input the audio. Okay, and for this one, basically it's also the code we record the data and explore the data to different kind of geometry using the value, using the frequency to create a geometry. So how can we do that? First things, if you see, let's take a look about the geometries. First things, we need to create reference line. So that's the first things. And then based on the reference line, we will create this kind of a polyline based on how many data we have per second. So it depends on this part, the record data. If we create 25 data or 15 data right here, you will create 25 data right here, 25 segments on the curve. And finally, it's about to move the height. So in order to move the height based on the value, based on the strength of the value, we need to explore these number again. So let's take a look. First things, here is about to create the lines right here. Here is about the line, and then we need to create a second line, so which means the segment line. So we're using the divide to divide the ref baseline and move them up based on the strength of the curve. So here is about the strength, using the strength of the curve to move the points to the top and connect them again to create a segment curve, polyline curve. Okay, so then we're using the color gradient to create the color for the curve. So that's the first part. Actually, we can try to organize them together. So here is about the curve right here. Let's Ctrl G so that you can know this part is about the curve. And I will Ctrl C, Ctrl V. Curve, polyline. And for this part, it's still about rendering, to render the color of the line. So let's Ctrl G. Move them up. So here is the render about the polycurve. Okay, so the second part is about the dots, the point, the circle on the top of the points. So how can we do that? Actually, it's just right here. If you remember, last time we used in the repo, we were using the sound capture to create the repo. So it's the same logic. This part is still about to render them to give all these dots some color. So it's the same things. So I would make them as one group. And let's code this one. Ctrl C and Ctrl V right here. Color of the dots. Okay. Or the circle, it will be better. Color of the circle. Right here. And for this part, it's about to generate a circle. First thing, there are two things we need to do. First thing, we need to create a circle. So this part is about to create the circle and using an offset to create a second one. So Ctrl C, Ctrl V, and Ctrl G to create a group. And let's call this one circles. And for this part, it's about to move the circle. Actually, this part is supposed to be here because this is about how to move the dot to the top. And for this one, it's about to move the circle to the top of the curve. So let's Ctrl G. If we turn on the preview, you can see here is about the curve, the dots, the circles. So let's call this one C, Ctrl V. Move circle to top. Okay. So basically inside this script, it contains, let's say, two different parts. First part is about to generate a polyline. So as far as you can see, here is about a polyline based on the curve we import from Rhinoceros to Grasshopper. And we're using the color gradient to generate the color for the curve. And the second part is about the circle. That's using the circle. That's using the strength of the song to create the size of the circle, and using move to move the circle to the top of the geometries of the polyline. And finally, again, using color gradient to generate the color for the circle. It sounds complicated, but actually it's the same logic. It's still using the sound of the volume and frequency as the motivation to motivate this script, and then extract the data from the sound about the volume and frequency to different geometries, and using the data to generate the size, the scale of the geometry. So that's the logic of this script. Okay, so let's start from nothing to everything. First things we need to do, and I will turn off the preview of the script right here so that it will not interfere our operating. And also I will stop recording. Let's turn off that one. Okay, but we still can keep this one here, so using this one as a reference. I will delete. First things we need to do is to create two lines. So I will draw two lines randomly. It's up to you. You can draw any shape you want. And the wireframe outside of the curve is just a reference for me. And I will put them into this layer. Show out everything. And I will delete the original one using a new one. Move them inside. Right now you still can see the curve right here. And I will tell you guys about why it was still here. And I will turn off that one so that you will not see them for now. Okay. Alright, so let's start from nothing to everything. So the first thing is still about sound capture. That's the soul of the script. So let's go to sound capture right here. And let's do that in a very quick way, okay? And type in, for the time period, let's type in 1. And change that one to floating number, floating point. Connect this one to it for the time period. And for the second one, the start-stop captures, let's go to parameter and find the triggers right here. And connect this one to start and stop sound captures. And that you can control the interval number, and I would prefer 5 microseconds. So the sew has pretty much done. And next part, we can connect panel right here, connect the value to the panel. And you can see for now it starts to work. And we can create the data recorder. Double click on empty space and type in data recorder. Connect this one to here. Okay, so I will stop record. Here is the soul of this script. Let's press Ctrl G to make sure them become a group, so it will be easier for you to operate. So the next part, let's take a look about our reference right here. First things, we need to import the curve to Rhino Grasshopper. So let's go to curve right here. Right click on this component and select multiple curve, which means select these two, press enter, finish the import these two curves to this component. Okay, and next part, right now they are just curve. So in order to make them become polyline, which means the lines which has segments, we need to divide this one into a couple different sections. So let's go to curve, divide, right here, or you can just double click on divide, this one. Let's connect the curve to here. As far as I can see, once you connect this one to the divide, it will automatically divide this curve into a couple different sections. And for now, the default setting of the sections is 10. And based on the number right here, if we record the limitation, the data is 10, we can make sure this one is 10. But for me, I think 20 would be better. Let's type in 20, commit change. So this part has to be 20. So let's type in maybe a 30 slider and type in 20 and connect to here. So for now, this curve has been divided as 20, divided into 20 segments. Okay. So for this part, it's pretty much done. The next part we need to do is to reconnect these points as new curve, a new polyline curve. So and also this polyline curve has to be changed change the height based on the strength of the volume. How can we do that? First thing is let's do the line first, and for now we can turn off this one. Turn off the preview, so we will not see that anymore. And for now, this one haven't been, and also right here, that's the line inside inside Rhinoceros. So we can hide this one as well. Control H to hide. Okay, so next part we need to connect these points as a line. So let's go to polyline, double click, or you can just type in line. But not this one, but this one. Okay. But for this one, is that okay for us to generate the lines? Well, it's a little bit weird. Actually, it doesn't work because for now, this one is only about 2 points line. So it's not good enough. We need to find another one. So which means let's go to find polylines. Right here. With polyline, we can import multiple lines here and connect them as one polyline. So let's connect this one to here. So for now, as far as I can see, they have to be connected into a polyline which has segments. But we need to make these polyline move with our volume. How can we do that? There is an old trick, always about math. We can extract the number right here and use multiplication to multiply this one with a base number and use that number to move the points. Okay, so let's do this. Go to math, multiplication right here, and connect this one to B, and let's give another one a slider. I think maybe 10 will be fine. So let's use this one and change this one to 5 or 4. It's up to you. And let's using this number to move. And how can we move? In order to move the lines, and we want to move the points, move the line in the, I think it's Z direction, to top directions, right? So in order to do that, we need to define the directions. Let's call out the move component first. So double click on empty space and call out the move component. As far as you can see, first things we need to define is about the geometry which we want to move. So which means the points right here. And the second one is about the motions. We need to define the direction and the distance about what we want to move. So let's go to find a vector right here. And this time I'm going to find a unit z vector and connect this one to unit z, which means we are going to move this number in z direction. So and connect this one here. So as far as you can see, now they have been moved up. So now let's connect this one to polyline. So it has become something like this. Okay, it works. Okay. The next part, the things we are going to do is to coloring this part, to coloring this one. And for now, for this one, for coloring this one, actually it's pretty much the same thing, so it's not that complicated at all. But before we do the coloring stuff, I also want to connect the line between between this one and the bottom one. For now, the bottom one disappeared, so actually we can connect this one again. Let's do that again. Hold up. Let's do this one again. Let's copy this one. Let's copy this one and connect, sorry, right here, not copied, but using the line component. Let's connect this one to A, and I want to connect the A point to B point, which means the bottom point. Connect to here. So now we have the vertical line right here. So that's the thing so I want to have. And also from the bottom, I also want to have another line right here. So let's connect this one here. So I have the bottom lines. So for now, we have three different polyline. First one, the top one. Second one, the vertical one. The final one on the bottom one. So now, since we have these three different segment polyline, I want to color all of them. How can we do that? Let's go to take a look using the color gradient and custom preview again. And this time we still need to using the domain and connect them to L1 and L0 and L1. The domain we are going to use is about the number of the data right here. Okay, so based on different strengths of the value, it will change different color. So let's take a look. Okay, let's go to flatten because for now there are multiple data inside. So let's go to Set, Flatten, connect the data to this one to flatten data right here. So right here, all the data structure will be flattened into one group, and it will be easier. So because we can make a sequence inside this group, and then we need to using the number in right here to create a domain. Let's go to bound right here. And with this component, we can extract the maximum number and the minimum number inside. And finally, go to deconstruct domain and to find out the maximum, the start number, and the end number. And finally, go to display and custom display. Basically, I will just find gradient color right here, gradient, and connect the start number to the L1, end number to the start number to L0, and end number to L1. So this one will be pretty much finished. And for this one, we can just connect here. Okay. And finally, go to custom preview. Connect the material to material which means the gradient to material. And for the geometry, connect this one to here. Hold on your shift key and you can do multiply connections. Okay, and for now we can turn off the preview right here because we don't want to see that anymore. All of them has been connected to here, so we just need to save the color right here. And we can change the preset so that we can see the difference. Okay, let's turn on the play key and let's take a look. So for now, as far as I can see, the color change based on my value, right? Isn't it cool? Yeah, I think it's pretty cool. Let's turn off this one. The next part, I will redo the structure for you guys. So here is about the lines. I think compared to the first one, it's more simplified because I think we don't have to separate this script into so many different sections. And here is about rendering. Okay, the next part is about the circles, right? So how can we do the circle? Actually, it's very easy because we have already moved the points to the top. So next part is about to generate a circle on the top point. So how can we do that? Very easy. Let's go to the surface geometries, or you can just go to curve. Let's find the circles right here and connect the moving points right here to the circle. For now, we didn't define the size of the geometries. So we need to define the radius right here. So which means here. And also again, we can extract the data from here and import them to here. But if we just directly import, probably it will be too large. Let's play again and take a look. Okay, so as far as I can see, now we have generated a circle on the top of the geometries. But I think it's too small, and also it doesn't have any color because for now it's just curved, but we can fix that later. First thing is I need to do some modification. For example, like a multiply right here and connect this one to here, radius. And so for now, all the points has been enlarged 5 times based on different value, right? And next part, since now we have this one, if you want a smaller, you can just decrease the number right here. The next part, the things we need to do, let's take a look at our reference. The things I want to do is to move this one because I thought just one circle would be a little bit boring. So I want to move them into probably 3 units higher, or 300 units higher. So let's do this. First thing is I create a larger circles on the same positions and then using move key to move them up. So let's go to offset right here. Sorry, not this one. Offset. Where is that? That's okay. That's just double click. Offset key, offset curve right here. Create offset. Connect this one to offset, and you can define the distance. And this time, I guess I want to maybe 100, maximum 100 slider. Go to the distance, something like this, right? And I want to move them up. So again, I need to define this one using the move key and the vector Z. Connect the geometry to move, and we can define the distance we want to move. So probably the number about what we're going to move is, let's connect this one again, 100. Okay, so pretty much done. And I will turn off that one because for now we don't need the same position anymore. We can just keep this one here. And another way is that you can directly connect the data to here. So it will become a lot of circle right here. But probably it would be too messy. So rather than doing that, I will just give this one a still number. It will look more clean. So since now we have this geometry right here, we can color in the circle and the moving circle right here. So in order to color them, we need to make them become solid surface. So let's go to surface, boundary surface. connect all of them inside, hold on your shift key and you can connect them inside. And for now, we don't need to see that anymore. So let's turn off the preview. Right click on the component and turn off the preview. We just need to color in that part. And for that part, I don't want to do that again. So let's just Ctrl C and Ctrl V, copy last part to here. Okay? And for coloring the circle, it's a little bit different from coloring the lines right here. For coloring circle, what we need to do is to know the area size of every circle and then make them become a new digital domain and using the maximum number and minimum number to define the L0 and L1. So it's a little bit different, but the logic is the same. First things, let's go to area right here to extract the number right here. And then blend all of them, make them become one group. And using the bound to extract to make them become a new domain. And in this domain, let's define the start number and the end number to L0 and L1. And for the duration, for the parameter in between these two numbers, we need to give them, actually this one is fine because we can just give them here, or you can give them this here as well. And finally, the group geometry. Let's connect the geometry to here, and it will be done. Okay, and we can turn off this one. Okay, pretty much finished, and we can change to another preset, probably this one. Alright, so let's play and take a look about the result. So for now, the color will change based on the module, and also as far as you can see, a lot of different size and geometry right here. So that's the things we are going to do. And if you just connect the bound number, the domain number to here, all the dots will keep the same color. But if you connect the area size or the boundary surface to the parameter in between L1 and L0, you can get multiple color. So that's the things we want to do. I will smaller the offset, probably it doesn't have to be too huge, maybe just 20. And let's keep the parameter play. So if I say something loudly, well, as far as I can see, it can create something, this kind of floating dot geometry. Isn't it cool? So let's take a look of the overall view. I will delete this part so that you can see more clear. And also, let's try to organize a little bit about the geometry. Here is about a circle, G, the circle, and I will delete this one. Here is about coloring the circle. So this is the script for this time. First things, capture the sound, and using the sound to generate polyline and coloring the polyline. And then using the points on the polyline to generate circle and make the size of the circle change based on the strength of the volume. Finally, coloring the circle, and everything will be done. Okay, so that's all for today. Thank you for watching. See you next time.